Okay, so in this video I want to go through question number 8 of quiz 9 because a lot of the students got it wrong, so I just want to go through it to make sure we all understand how to do this sort of question. So question number 8 says, a nutritionist believes that obesity is more prevalent among Americans, or more prevalent among American adults now, I guess, as opposed to in the past. He discovers that in a study conducted in 1994, 380 of the 1630 randomly chosen adults were classified as obese. In a more recent study, he finds that 726 out of 2350 randomly chosen adults were classified as obese. Okay, so at alpha equal 0.05, do the studies provide evidence to support the nutritionist's claim that the proportion of obese adults has significantly increased since 1994? So first thing we need to notice is that this is a hypothesis test for proportions, not sample mean. Okay, so when we're writing our hypothesis, we should not say mu, rather we should say p, right? This is a hypothesis test for proportions. You have to recognize that while reading the question. We're talking about the proportion of obese adults in 1994 versus the proportion of obese adults in more recent years. So first thing, I'm going to define some notation. I'm going to define 1 to be 1994. So that way, when I say N1, N2, I know what I'm talking about. So 2 is going to be recent. Okay, and then next, I'm going to define my HO, HA. So P1, since P1 is referring to 1994, so this is going to refer to more, or this is going to refer to the proportion of obese adults in 1994. So the nutritionist believes that obesity is more prevalent than it was in the past, right? So the proportion of obese adults is less than it is now, or in more recent years. So the alternative, or the null hypothesis, will be the exact opposite. Now remember, the null hypothesis always has the equality. Okay, so you want to make sure that your null hypothesis has the equality sign. Okay, so now it's just a matter of knowing what the test is. So this is a z-test. Okay, all tests for proportions are a z-test. Let's write down some of the things that we read when we were reading the question. So first thing is, tells us that there are x1, the number of obese adults in the past was 380. N1, the sample size of that study, was 1630. Okay, then x2 is 726, and N2 is 2350. Okay, so now we need the proportion of adults who are obese in 1994. So to get that, you just divide these two numbers, right? So there are 380 obese adults in 1994 out of the 1630 that are sampled, and in more recent years it's 726 out of 2350. Okay, so we can use Excel to calculate these numbers. Right now I'm just going to leave it, and then I'll go find those numbers in a minute. Okay, so the next thing that we're going to need is this P bar. Remember this P bar? This was x1 plus x2 divided by n1 plus n2. It was kind of like a averaging of the different proportions in some sense. So this is going to be 380 plus 726 divided by 1630 minus 2350. Okay, so now we're ready to, let's calculate these numbers. So I calculated them in Excel already, so we can just look to the Excel file. You can just use a calculator, or you can use Excel, it doesn't matter. So 0.233 is p hat 1. So let's go ahead and write that down. 0.233 p hat 2 is 0.31, round. 0.31, and then the p bar, okay, is 0.278 round. Alright, then we're ready to calculate our test statistic. So the test statistic is up here. This is p hat 1 minus p hat 2. Okay, minus the p1 minus p2, but that the p1 minus p2 is 0 because we assume the equality in the null hypothesis. So p1 equals p2. So if you were to say minus p1 minus p2, then that would just equal 0. So we can just leave it. We don't need to include it since it equals 0. Minusing 0 is nothing. Okay, then we have p bar and then q bar. Okay, that times 1 over the sample size for the first group plus the sample size for the second group. Okay, all of that is then square rooted. Okay, you can use a calculator or you can use Excel to calculate this. So I've used Excel. Okay, if you want to see my my formula, you can see it's written up there. I've used cell references, like I've just clicked on the cells, but you'll get the same answer if you use a calculator. So negative 5.25. Alright, now lastly I need to calculate the p-value. Now we can rearrange this. P1 minus P2 is less than 0. Sometimes it's helpful to rearrange, and so then you see this less than 0 thing and you know that this is a left-sided test. Okay, so this is a left-sided test. Here's negative 5.25. It's a z-test, so the p-value is going to equal this norm dot dist negative 5.25 comma 0, 1, true. Okay, you don't need to do 1 minus or anything for this one, right? Because it's the area that is behind negative 5.25, which is exactly what norm dist will give you. It gives you the area that's behind the number that you put in. Okay, so this is calculated in Excel. You see it's approximately 0. So we can just write approximately 0. Okay, so last step, don't forget this, really important step. You lose big points for not including this last step. You need to say we reject HO. And why did we reject HO? Because this p-value is less than alpha. Okay, alpha was 0.05. Okay, so 0 is less than 0.05. So we reject HO. And then we also don't leave it there. We need to make this final statement that there is evidence to support that the proportion of obese Americans has increased since 1994. Okay, so you need to make a statement at the end. It goes back to the original question, okay? Answering their original questions. This is kind of a statement that a lay person could understand. You need that statement to finish up.